Hi, in this video I will discuss only selected questions from 25 to 50 which are requested by you. Okay, so let's start with the question number 26. The balance length of the potentiometer are 400 mm and 588 mm when connected to Y and Z respectively. What is the resistance of the resistor R? Now we want to find the resistance of this R. So when X is connected to Y, the balance length is 400 millimeter. Okay, so if the potential gradient is K, K is the potential gradient of the potentiometer wire. So now I can write, so when X is connected to this point, the potential difference, this potential difference is balanced by the length by the potentiometer wire. So now we can equate the potential differences. This potential difference is equal to this difference. Okay, so if the current passing through this circuit, if I consider it to be capital I, so I can write the here potential difference is, I can write I times 100 ohm is equals K times the length is 400 millimeter. So I take this as my equation 1. Okay, and the next, when X is connected to Z, the balance length is 588 millimeter. So when X is connected to Z, so this potential difference is balanced by the potentiometer wire. So now I can write here the potential difference is I times 100 plus I times R. So I can write I times 100 ohm plus R. This potential difference is balanced by K times 588 millimeter. So this is my equation 2, and we want to find R. So I'll divide equation 2 by equation 1. So dividing equation 2 by equation 1, I get, so I cancels off and K cancels off in the right hand side. So I get here 100 plus R over 100 is equals 588 over 400. So now what we have to do is we have to simplify this equation and subject R, then we get the value of R. So here I can write 100 plus R is equals 588 over 400 times 100. So here 100 and 400 cancels off, so we get here 4. Okay, so now I can write 588 divided by 4, then I get 147. Taking this 100 to the other side, I get 100 here. So R is equal 47 ohm. Okay, and the next question I'm supposed to do is 27. 3 point charges are placed in the corners of a cube. What is the net flux through the ABCD surface? Okay, so here we are supposed to find the flux going through this surface due to these 3 charges. So if I consider each individual charges, first thing that you have to understand, the flux going through this area due to this charge is 0, because this area is parallel to the flux coming from this charge. So due to this charge it's 0, so we can ignore this charge. And now we want to find the flux going through this area due to this charge and this charge. Well, actually this is a easy, I think you are very familiar with this problem if you really practice with past paper questions. Okay, so now I'm going to find out the flux going through this area due to this charge. For that, I'm going to consider another cube. So let me draw first. Well, so this is the cube made of 8 such cubes. Okay, and this cube is exactly at this point. Then this charge would come to the center of this big cube. Okay, so now we can write the Gauss law. We know the net flux is equals to net charge enclosed by the Gauss surface divided by the permittivity. So using Gauss law I can write the net flux I is equal sigma q over epsilon. So psi is equals sigma q is, so the charge I only consider this charge, so at the it is the material, so it's simple q over let's take permittivity is epsilon. Okay, and we know psi is equal electric field intensity times the area. So here I'm going to consider this area is capital. Okay, so now we want to find the net flux going through this cube. So now I can write here net flux, it's that is equal E times, so the area, the whole area I can one, so here 4a in this one side 4a. Okay, so we have so 6 faces of a cube, so the total area is 4 into 6 24a. So this is the net flux. Okay, is equal q over epsilon. So now we have the net flux going through this cube, but now we want uh, to find only flux going through this area, so that is a. Okay, so for that I have to divide 24, so we get e into a is equal q over 24 epsilon. Okay, and if I consider this ABCD area as A naught, and so I said this whole box is here, so from we can say this A naught into 4 is equal A, so I can write A is equals 4 A naught, right? So I can substitute that in this equation, then I get V times 4 A naught is equals q over 24 epsilon. Okay, so this is the flux going through this area, but we want to find the flux going through this area, so I want to divide by 4, so then I get e over e times a naught is equal q over 4 times 24 epsilon. Okay, so okay, so far we calculate the flux going through this area due to this charge. So now we have another charge, and that's also same value, therefore we get the flux is twice this value, no? So we can write the net flux equals q over 4 times 24 epsilon times 2, so that is equals q over, so 2 and 4 cancels through, 2 into 24 48 epsilon. So that's the net flux, so answer is second one. Okay, and actually speaking this is not the exact value, this is the most approximately close value. Okay, if you want to if you want to know why, let me know. Okay, I can explain you that why it is the approximately close value, not the exact value. Well, and the next question. Okay, question number 32. What is the current passing through 0.5 ohm resistor? So here we want to find out the current passing through this resistor. Actually this is a very easy question, just a use of Kirchhoff law. Okay, so yeah, let's find out. Okay, so I'm going to use Kirchhoff law. Okay, so so first what we have to do, we want to mark the current. So to mark the current, first what I have to concern is which one is the largest battery. So we have this one is the largest battery, so I will start to mark the current from here. So we can see if the current comes here, it breaks into two sides. So let's take here the current is A plus B, and so current to this side A and this side B. So what we want to actually find the value of B. Okay, first I'm going to consider this loop. Okay, so using Kirchhoff law, we know sigma E equals sigma IR. So in this loop I have first 12 volts, and actually that's all. Is equals the current. First we have A plus B times 1 plus A times, so here again current divides. Okay, so if you going to take this A as here again like current going to this side C and current coming this side A minus C, what you are going to do is you are making complicated. So what we can do is we can find the equivalent resistance between these two. So if you take the equivalent resistor, it's 1 ohm, right? These two are parallel, so it's 1 ohm. So here we have A times 1. Okay, so now we can write 12 is equals A, and here 2A plus B, so this is equation 1. Okay, and again now I can consider the Kirchhoff law in this loop. Okay, so we have now 12, okay, 12 and minus 8 is equals A plus B times 1 plus B times 1 and B times 2.5 plus 0.5. We have B times 2.5 plus B times 0.5, that is actually B times 2.5 plus 0.5. Okay, so here 12 minus 8 we get 4 is equals A plus, here we get B and 3B, 2.5, 0.5, 3B and B 4B. Okay, so I take this my equation 2. So from equation 1 and 2, I can write 4 equals A plus 4 times from this equation using 1, B is equal 12 minus 2A. B equals 12 minus 2A. So 12 minus 2A. So simplify this, we get 4 equals, so here A plus 4 into 12, 48 minus 8A. So we get here minus 7A. If we take this side, plus 7A is equal 48 minus 4, 48 minus 4 we get 44. 7A is equal 44. Oops, sorry, I made a mistake. So here if I consider this loop, okay, so here 12 volts, sum of EMF plus 8, so here it's plus, so here I get 20. Okay, so I'll write this again. Okay, so from these two equations now I can write want to find B. So from me I take equation 1, that is 12 equals 12 2 times A is equal, from this equation 20 minus 4B, okay, plus B. Why I'm doing this is because we want to find the B, so no point of wasting time for finding the value of A. So we'll subject A from this equation and substitute in this equation. So subject A from this equation and substitute in this equation, so we can directly get value for B. So simplifying this equation, we get 12 equals 40 minus 8b plus b minus 8b plus b minus 7b. Taking this to side, decide 7b is equal 40 minus 12. So b is equal 40 minus 12 is 28. 28 divided by 7 which is actually 4. So b is 4 ampere. So answer is third one. So this is a very easy question from Kirchhoff law. Well, and let's move to the next question. Question number 37. Two soap bubbles of radii R1 and R2 combine to form a big soap bubble of radius simple r. The relationship between R1, R2 and R is given by. So here actually we know the volume of the soap bubble is conservative, but we can't write any formula for the volume because this is a soap bubble. Okay, if this is like water droplets or something, then we can write the equation for the volumes. So here actually we have to deal this with the energy conservation. So here soap bubble, it has a surface energy due to the surface tensions. So now I can consider two soap bubbles, radii R1 and radii R2. These two combines to form a radius of R. Okay, so if this has a surface energy E1 and this has surface energy E2 and this has, let's say, surface energy E, if we consider the energy conservation, so I can write E is equals E1 plus E2. Okay, and surface energy of this one is, I can write, if the that is T times, I can write T times for 5 R squared, where T is the surface energy per unit area, or else you can say surface tension coefficient. So it's the same soap bubble, so T is same for all three. So now I can write E1 is T times for 5 R1 squared plus T E2 is T times 4 5 2 squared. So T times 4 5, T times 4 5 cancels off. Okay, so we get R squared is equal R1 squared plus R2 squared. Therefore R is equal R1 squared plus R2 squared square root. Okay, so not a big thing. Okay, and let's move to the next question, 38. So in this problem we have the moment of inertia of a thin uniform circular disc of radius r is I about its center axis. Okay, now a circular piece of radius r divided by 2 is cut and taken out from the disc as shown in the figure. So here from the disc of radius r, a disc of r over 2, radius of r over 2 is cut and taken out. Okay, the new moment of inertia of the system is, so now we want to find the moment of inertia of this system. So if I consider the mass of the disk is m, okay, mass of this whole disk is m, and density is, let's say, rho. Okay, so now I can write an equation for I. We know I is equals half m r squared. Now I can consider the disk of radius r over 2 if that has a moment of inertia I1. So I can write I1 is equal half times the mass of this part, let's take that is m naught over radius squared, so r over 2 squared. Okay, so here I want to find the m naught. So how can we find out? So I consider the rho is the surface density, that is rho, it's a uniform disk. So it says uniform circular disk. So now I can write the mass and density relationship. So rho is equals mass times this area of the circle 5 r squared. Okay, so now I can write m naught equals rho times this area. So this area is 5 r over 2 squared. Okay, So I get m naught equals rho. I can substitute this value, so m over 5r squared times 5r squared over 4. So we get from this m naught equals m over 4. So I can write I1 is equals half m over 4 times r squared over 4. So now the new moment of inertia of the system, now I can write that is let's say I new, that's equals to I minus I1. So we have I is half mr squared minus so let's keep that is as I minus I1. Now I can write I1 is half into mr squared times 1 over 8. Okay, so I can write I minus, so half mr squared is I, so 1 I divided by 8. Okay, so I can write this is equals to, if I take out 8 minus 1 over 8, so we get 7I over 8. So answer is second one. Okay, now question number 40. What is the current through RL resistor? Well, actually this is a very basic question in transistors. Okay, so we want to find out IC. Okay, so first, so here we can see RB value is given, beta value is given, and VB is given. So beta, we know beta, so here this is common emitter configuration, therefore beta is equals to IC over IB. So if we can find out the IB, then we can find the IC because beta is given. So can we find IB? So that I can consider the potential drop in this way. So we can write the 6 volt is equals IB times RB plus VBE. Okay, so here 6 equals IB times RB is 120 kilo ohm, 120 times 10 to power 3 plus VBE is 0.6, 0.6. Okay, so just simplify this equation and then we get a value for IB. So we get IB is equal 0.045 times 10 to power minus 3. So now we can find the IC. IC is equals 0.045 times 10 to power minus 3 times beta is 100. So we get IC is equals to 0.045 into 100 is 4.5, 10 to power 3 is milliampere. So the answer is first one. Okay, 43. What is the nuclear binding energy of a 2,4 helium atom? In your exam, here it was H, but it should be H helium. Okay, H, but I won't give free marks for this because you should be able to understand that is helium, not hydrogen, because given value is helium, and also 2,4 that configuration is for helium. Okay, so what is nuclear binding energy? That is the minimum energy that would be required to disassemble the nucleus of an atom. Okay, so now we have a helium atom. So if we take helium atom, let's take this helium, and we want to break that into its constituent nucleons. So we have in 2 for helium, so 2 protons and 2 neutrons. Okay, so in this process we need to supply some energy, so that energy will be stored as a mass. Okay, so we can find out the delta M in this process. So if we can find out the delta M, and from the one of a beautiful equation in physics, which is delta E equals delta M c squared, or else E equals mc squared, this equation. So from this equation we can find out the required energy. Okay, so now let's first find out this delta M. For delta M, now I can write delta M is equals, there are 2 protons, so 2 into mass of a proton is 1.00728 U. Okay, plus 2 neutrons, so 2 into 1.00866 U minus mass of the helium 4.0015 U. So if you simplify this, we get delta M is equals to you get delta M is 0.03038 U. Okay, and now we can convert delta U into kilogram using this one. So delta M is equal 0.03038 times 1.66 times 10 to power minus 27 kilogram. So here you can use a logarithm to simplify these kind of calculations. Okay, and anyway, we get delta M if you do this. 0.0504 into 10 to power minus 27 kilogram. So now we have a change in mass in kilograms, that is, we can see it's a very small mass, right? So that's the change in mass, and now we can find the energy using E equals mc squared. So now that energy, now I can write 0.0504 times 10 to power minus 27 times c squared, 3 into 10 to power 8 squared. So you get E is equals to, to simplify this, you get 0.4536 into 10 to power 27, here 16, then we get 10 to power minus 11. And now we have this in kilo, so this energy is in joule. Okay, we get this energy in joule, and then we want to convert into electron volt. So what we have to do is we can divide this by this value. Okay, so I get E is 0.4536 times 10 to power minus 11 divided by 1.6 into 10 to power minus 19. Okay, so we get E is equals 0.2835. So minus 11, here we get minus 19, then 10 to the power 8. So E is equal 28.4 into 10 to power 6 means mega electron volt. So answer is third one. Okay. Okay, and the next one, 44th question. Consider the circuit shown in the figure. The graph shows the waveform of the applied voltage and the current through the load. Okay, the average power dissipation of the load is, so we want to find out the average power dissipation. We know power dissipation is P is given by VI. Okay, so if I consider this time between 0 to t of 4, the current is 0, right? Current is 0, so I don't, doesn't matter whatever the value of Vm, if current is 0 means power is 0. Okay, so in this time interval we have the power is 0. So and if I consider this power in this time interval, okay, so here the current is 0, okay, and here the current is Im maximum. So here now I can find the average of this one in this particular time gap. The average I can write 0 here because current is 0. 0 times Vm we get 0, so power is 0, and here the power is Im plus Vm, Im times Vm. Okay, so in this particular point, so here it's increasing linearly, so we can take the average like this, okay, divided by 2. So this is the average between this time interval, and we want to find the average between this time interval. For that, now I want to take this value, okay, plus 0 divided by 2. Okay, so we get here Im Vm over 4. So that's the answer. Okay, and the next question, 45. A and B, two masses, are attached to the ends of a light inelastic string as shown in the figure. The string goes over a frictionless pulley. The mass of A and B are n1 and n2 respectively, where n1 is greater than n2. At t equals 0, A and B are in the same level and they start their motion at rest. The speed of A when B moves h over 2 distance vertically upward. Okay, so actually this is a very easy question. This is a we can use, so since this is frictionless pulley, we can use energy conservation principle, right? So using energy conservation principle, let's say this is at t equals 0. Okay, A is heavier and this is B, and B moves h over 2 means A also move h over 2 distance because the string is inelastic. Okay, so B moves in this direction, VB, and A in this direction, VA. Okay, and let's take this is the gravitational potential energy 0 level. Okay, so here is the same. Okay, so now I can consider at t equals 0 and t equals t naught, and using energy conservation principle. So using energy conservation principle, total energy at t equals 0 is equals total energy at t equals t naught. Okay, so at t equals 0, the potential energy of both particles is 0, so 0, and also both particles, both A and B, start their motion at rest, so kinetic energy also 0 is equals, and kinetic energy of A, that is half m1 VA squared. plus kinetic energy of B half m2 VB squared plus potential energy of A. So potential energy of A is minus m1 G H over 2 plus the potential energy of B m2 G H over 2. Okay, so one more thing here, it's an inelastic string. Since it's inelastic string, speed of A and B is the same. Okay, if this inelastic string, if the string here in this end moves some h over 2 distance in t naught time, so here also it moves in h over 2 distance in t naught time, so the speed will be the same. Okay, so let's take that speed is va equals vb equals v. So now I can write down, I take these two terms to this side, then I get m1 minus m2 g h over 2 is equals half, so here v squared and this is v squared, so I can take a half v squared common out, m1 plus m2 v squared. Okay, so subject to v squared we get, so here 2 cancels off, v squared m1 minus m2 gh over m1 plus m2. Well, so we want to get v, so v is square root of this value. Actually I think I made a mistake in this problem, I have to put square root to each term here. So I give you this free marks and let others also know about this. Okay, question number 47. What are the suitable values of R1 and R2 to obtain a variable voltage gain in the range of 10 and 100? Okay, so we know the voltage gain of IC is VA is equal 1 plus RF over R1. So RF is this part, the feedback resistor, and R1 is this part. Okay, and from this equation we have maximum voltage gain when this term is maximum, and minimum voltage gain when this term is minimum. Okay, so let's say the maximum voltage gain is 100, so now I can write 100 is equals 1 plus, now we want the maximum of this value, so the maximum of this value when this RF is maximum and this is minimum, so we can take a maximum RF when we connect this to this side, right? So here we get RF is R2 plus 10 kilo ohm, that means 10 kilo ohm over R1. So from this equation we get 100 minus 1 99 R1 is equals R2 plus 10 kilo ohm. So this is my equation 1. Okay, now let's say the minimum voltage gain is 10, so I can write 10 is equal 1 plus, now we want to get a minimum of this value, so this is minimum, this value now we want the minimum of this value. Okay, and we know when this is gets minimum when numerator becomes minimum and the denominator gets its maximum, so what we can do is we can take this terminal and connect to this side. Okay, so we get here R2 over R1 plus 10 kilo. Okay, so 10 minus 1 9, so from this we get 9 times R1 plus 10 kilo ohm is equal R2. This is my equation 2. So now I can substitute equation 2 in equation 1, that means the value of R2, so I get 99 R1 A equals R2 is 9 times R1 plus 10 kilo ohm plus 10 kilo ohm. So let's simplify this equation. Then we get 99 R1 9 R1 plus, so 9 times 10 90 90 plus 10 100 kilo ohm. So 99 minus 9 R1 means 90 R1 is equals 100 kilo ohm. So 100 divided by 90, we get R1 is 1.11111, so 1.1 kilo ohm. And now let's substitute this value in equation 1 to find the value of R2. So here it would be better, we can so in this equation we have 99 times R1, so I can substitute R1 from this. R1 is equals 10 over 9 kilo ohm, right? So I put that value here, 10 over 9 kilo ohm is equals R2 plus 10 kilo ohm. So 99 divided by 9 11 11 into 10 is 110 kilo ohm is equal R2 plus 10 kilo ohm. So we get R2 is equal 110 minus 10 100 kilo ohm. So the answer is first one. A circular conducting loop is moving through two magnetic field regions at constant speed. The magnetic fields are equal in magnitude and opposite in direction. So now we have two magnetic fields. One is into the paper and the other one is coming out of paper, and the both value is B. Let's say this also B and this also B. Okay, and this is into the paper, and here this is coming out of paper. Okay, the induced EMF of the loop with time is given by, so we know at t equals 0 it's 0, right? Okay, so everything start from 0, and when it moves towards this, the area that interferes with the flux is going to be increases, right? But it's not linear. Okay, so we know from Faraday's law I can write E is proportional to delta psi over delta t, and we know B is equal psi over A. From this I can write psi equal B times A. Therefore I can write delta psi is equals here we have constant B times delta A. So I can write E is proportional to B times delta A over delta T. So we can see this E is proportional with the area. Okay, the area that's going to be interfere. So it's starting from 0. Okay, and when the loop goes half of its value, so we can see the change in area is maximum. So here we have 0 area, here we have a large area, that is half phi r squared. Okay, so that's the, now here it's changing in area is going to be maximum when it's half, it's enters this. So now we have something like this actually, yeah, and in maximum, and when again the changing area is decreases. Okay, rate of change in area is decreases, and it comes to, when it comes to here now it's 0 because the area is constant. When it comes completely inside to this, the area is going to be constant, right? Okay, so we get something starting from 0, and when it comes to here, when this part comes to here, the change in area is maximum, and again it's decreases, and it's when it comes to completely it's 0. So according to that, now it all agrees with that. Okay, all the graphs agrees with that. So now when it's completely entered to this and it's moving towards the field, we can see the area that interferes with the field lines is constant, it's not changing. Okay, so now then we have from this equation change in area is 0, therefore electric field 0. So after that we want to have 0. Okay, 0. Okay, everything agrees with that. And when it comes to here, okay, now we can see the field changes twice. So here it changes like from 0 to capital B, right? And when here, sorry, it's, let's say here 0 to plus B, let's say this is plus direction into the board and this coming out of is minus B. Okay, so here when it comes to here, it changes 0 to B, right? But here it's changing like plus B to minus B, therefore it's twice but it's in opposite direction. Okay, so should be twice in opposite direction. So the only one agrees with that particular argument is this one. Okay, because it changes twice. So here it's like 0 to B, but here it's like plus B to minus B. So the change here is twice, the change in here is twice the change in here. So the answer is first one. Okay, okay, and the last question that remaining to do is 49. Okay, so in this problem we have a system of vectors a b b c c d b d a d e d e f a e and f a are acting on a regular hexagonal. Okay, so regular hexagonal means each sides are unequal in length. Okay, the resultant vector of the system is, okay, well, so now we want to find the resultant vector. So if I consider f e and b c both are the lengths are equal, right? So and these two are parallel, so we can see both equal in magnitude, opposite in direction, so these two cancels off. Okay, similarly now we can cancel f a and c d. Okay, equal in magnitude, opposite in direction. Okay, and now we have only okay, now we have only a e e d b d a b and a d. So if I consider a e and e d, so it's go here and comes to here, the resultant of a e and e d is a d, right? The resultant of a e and e d is a d. Similarly, resultant of a b and b d is a d. So now we have a resultant of a e and e d, that is a d, plus resultant of a b and b d, that is b d, and already we have a d there, sorry, and already we have a d there, so that is the resultant of this whole system. So the resultant is 3 a d. So answer is first one. Well, so I discussed all the questions that you needed an explanation. Okay, and one thing here, you have to add free marks for this problem, question number 45, because there is a square root missing. Okay, so that's all. Take care, study well, wish you all the best.